Hello everyone. In this video, I'll be discussing about major abnormalities of high voltage systems. Let us move on to the discussion. As you can observe, the abnormalities of high voltage systems are given below. So we have the following abnormalities such as voltage sag, then voltage swell, power loss, fault occurrence, harmonics, poor power factor or you can call low power factor, and finally insulation failure. These are the popular abnormalities which are taking place in high voltage system. Now I would like to discuss individual abnormalities. Let me move on to voltage sag. What do you mean by voltage sag? Let us check the definition of voltage sag. Voltage sag is nothing but a temporary reduction in the normal AC voltage. You can observe here you can observe there is a voltage reduction. In this range, everybody can observe there is a sudden voltage drop, but it will not prolong permanently. It is only a temporary. For example, a momentary sag is a variation which lasts for a period of 0.5 cycle to almost 2 seconds, usually in the results of short circuit somewhere in the power system. It is a temporary and a duration which we can observe is at least 2 seconds. And also the main reason for occurrence of sag is due to short circuit in somewhere else in power system. We can explain in another terminology related to sag, that is called sustained sag. What do you mean by sustained sag? Instances of longer duration of low voltage are generally called sustained sag. Now you can observe this will be the sustained sag. The second diagram you can observe the sustained sag. The first diagram, that is a normal type of sag. That is one of the abnormalities which will be taken place in high voltage system. Now let us understand what do you mean by voltage swell. It is just opposite to that of voltage sag. Voltage swell is an increase of power frequency voltage. There is a sudden increase. You can observe. See, there is a sudden increase. Here you can observe. Here also you can able to observe. There is a sudden increase of voltage at a particular instant. It prolongs for 2 seconds. Okay, so you can sudden rise, you can observe. See, there is a sudden rise of voltage. It may be due to opening of any kind of switches which are used in high voltage system. There will be a lot of switch gears. Whenever you are opening the switch gears, there is a sudden rise of voltage. Okay, so that is the reason for voltage swell. Now we can able to define momentary swell. What do you mean by momentary swell? A momentary swell lasts from 0.5 cycles to 2 seconds. And what do you mean by sustained swell? In the sense, a sustained swell lasts for longer period. You can see this is a momentary swell. This will be the sustained swell. This is another power quality issue. And we can say that this is another abnormalities which are taken place in high voltage system. Moving on to the third abnormality, that is called surge. In the previous video, I have explained the important information regarding surge. You can observe the waveform. So there is a sudden spike. This is due to lightning. And here also switching surges you can able to observe. That means switching transient. It is mainly occurring due to lightning. Then you are using lot of switch gears, opening and closure of switch gears. Then there will be inductors and capacitors in the transmission line. Because of these issues, because of these constraints, the voltage surges will be generated. It is basically oscillatory in nature, and the duration is very less. The surge is a sub-cycle disturbance lasting for a duration less than a half cycle and mostly less than a milliseconds. Duration and the time period that is mentioned very clearly. We can able to observe transient or spikes, as I have already shown you the position where the surges are taken place. You can able to observe very clearly. It is merely explaining the diagram itself as a self-explanatory diagrams. Mainly lightning. Due to lightning, these kind of surges will be generating, and also due to the operation of switch gears, these kind of surges will be originating. This is also another power quality issue. Moving on to harmonics. The main origin of harmonics is due to non-linear load. If you are using non-linear load, and of course we can say there is a harmonics. Now I would like to state the peripheral effects of power electronics. If you are using inverter or rectifiers, whatever it can be, definitely there is a power electronic interface. Due to that, the harmonics will be generated. It is one of the severe power quality issue. The main problem of harmonics is actually your waveform should be purely sinusoidal. But the thing is, you will be able to get the distorted waveforms. In spite of getting pure sinusoidal waveform, you will be able to get the distorted waveform because of harmonics. There are different order of harmonics like third harmonics, fifth harmonics, 13th. As you can observe, the third harmonics and fifth harmonics are too dangerous. So we have to reduce the effect of third and fifth harmonics as much as possible. Let us define the harmonics. In an electric power system, a harmonics is a voltage or current at a multiple of fundamental frequency of the system produced by the action of nonlinear loads. What are the examples of nonlinear loads? Inverters, rectifiers, discharge lighting, or saturated magnetic devices. So this is the basic definition of harmonics. Because of harmonics, there will be a distortion. Definitely, it is one of the severe power quality issues. So with the help of total harmonics analyzer, you can able to measure harmonics analyzer. You can able to measure total harmonic distortion. Harmonic analyzer can be purchased. Moving on to the third point, harmonics can cause problems of different electrical equipment such as generators, then electric motors, transformers, capacitors, and cable. Definitely, the quality of power will be degraded due to harmonics. As finally, we can say that eventually the system efficiency comes down. That is another severe drawback or another severe impact. I should say that impact, one of the severe impact of harmonics. Okay, so these are the main impact of harmonics. Try to reduce harmonics as much as possible. There are different methods. So we have to study a new course on power quality issue. Now I would like to explain about poor power factor. That is another one of the impact which is influencing directly on the high voltage system. If you are operating the load with the power factor, losses will be getting increased. This results reduced efficiency. So you need to improve the power factor. If you want to improve the power factor, you have to go for the capacitor bank. If you are using capacitor bank, it may cause the problems like ferro resonance. I will be explaining the ferro resonance issue in the upcoming session. Ferro resonance. This is one of the major terminology. Ferro resonance. Okay, if you are using capacitor bank, we have to consider the effects of ferro resonance. Insulation failure is mainly occurring due to the high voltage. If you are using poor quality of dielectric material, obviously there is a probability of occurrence of insulation failure. So you have to consider the proper dielectric strength of dielectric material. Whenever you are designing, you have to undergo sufficient testing, then it should be implemented in the practical system. Otherwise, puncture or flashover will be taken place. Okay. Finally, I would like to conclude the session. So in this session, we have discussed about the major abnormalities which are occurring in high voltage systems such as voltage sag, voltage swell, power loss, fault occurrence, harmonics, power factor, poor power factor or low power factor, and finally insulation failure. So I have explained individually. I have referred the following textbooks and a few websites such as electric4u.com, circuitblog.com. Likewise, I have referred different websites, even Wikipedia as well.